Hi everyone, here we come at the last chapter. So before we start, let's recall what a polynomial model is. So polynomial regression is actually an extension of linear regression where unlike linear regression, which fits a straight line, polynomial regression can capture more complex curve relationships in the data by including higher order terms. So this makes it a powerful tool for modeling nonlinear pattern. So basically in in polynomial regression, we will have this kind of model, y equals to beta naught plus beta 1 x1 plus beta 2 x1 squared plus error. So this is actually called as a second order model, or sometimes can be called as a quadratic model. So in this video, we will go through polynomial regression using an example. So we will explore how to interpret the results using the given output. So here is the example. Let me just read the example for you. So a researcher conducted a preliminary small-scale experiment to examine the impact of the change rate, x1, here is the first predictor, and temperature, x2, on the lifespan of a new type of power cell. So here is our dependent variable, the lifespan of the power cell. So a regression model was developed and the results were summarized in the following Minitab output. So this is the output given the ANOVA table, the coefficient table, the parameter estimates. So this is polynomial regression model because we can see the quadratic effect here, and here is the interaction effect. So before we go through the question, so let's just see what is interaction effect actually. So interaction effect is actually can occur when the effect of one independent variable, for this case, let's say x1, the effect of x1 on the dependent variable on the y actually depends on the value of another independent variable, in this case x2. So that's the meaning of interaction effect. Alright, so let's just go to the question. The first question, to provide the estimated regression equation obtained from the analysis. So this is actually simple. It's like the multiple linear regression or simple linear regression that we have learned previously. So you can answer this question based on this table. So y hat, this is the constant or intercept value. Alright, so here is the regression coefficient for the first variable, for the first predictor, because of the minus. So you have minus here. So you just copy from the table 75.5 x2. And here is of a quadratic effect for the first predictor. Alright, and then this is the interaction effect. So that's how you write down the estimated regression equation. Alright, next question is to apply the p-value approach. Be careful with the question. The question asks you to use the p-value approach, not the critical value, not the traditional approach, to test the significance of the regression equation at 5%. So this is our alpha, our significance level, and explain your findings, interpret. In other words, you have to interpret your results. Alright, so let's see how to answer this question. So write down the hypothesis. So because you have the 5 regression coefficient here, representing for each predictor, and also the quadratic effect and the interaction effect. So beta 1 equals to beta 2, beta equals to beta 3, beta 4, beta 5, and equals to 0. So for alternative, you can write down as at least one of the regression coefficient here is not equals to 0. So because the question asks you to use the p-value, so you just go through the p-value here, because this is for model, right? Yeah. So this is the p-value 0.0109. Alright, so since p-value is less than 0.05, so we reject H null. Otherwise, if it is greater than 0.05, so we fail to reject. But in this case, because it is less than 0.05, therefore we reject H null. So the conclusion is our regression model is significant. So the next question, to assess whether the quadratic terms for both predictor variables. So remember, we have two predictors, so each quadratic terms for each predictor variables. Alright, and then by performing an appropriate test at a 5% significant level. So let's look at how the solution is. So this is for the first one. Alright, this is for the first predictor. I mean, it is for x1 square and x2 square here. So you have to provide both solution. So the test statistics here, because the question didn't ask you to use the p-value approach. So look at that. You can have your t here 1.347. Okay, and then this value you can obtain from table actually. So this is T alpha over 2. Your alpha is 0.05, so you divide it by 2, so you will have 0.025. And that degree of freedom, your number of regresses. Okay, so since our test statistics here is less than your critical value, so we accept or we fail to reject H null. If it is greater, then we can say that we reject H null, but because in this case it is less than the critical value, so we accept H null or fail to reject H null. And then the conclusion is the quadratic term for change rate for the first predictor is not significant, because we fail to reject H null. If we reject H null, then we can say that the effect of the quadratic term effect is significant. So same goes to the second quadratic effect for the second predictor. But in this case, we have this negative value. Alright? Okay. So again, it is less than the critical value that we obtain from table. So we can say it as we can conclude or we can decide to fail to reject H null. And the same conclusion we have, the quadratic term for change rate is not significant. Alright, let's move on to next question. Evaluate the necessity of the interaction term in the model using a 5% significance level. So this question actually want you to conduct hypothesis testing as well to know whether, to identify whether the interaction term is significant or not. Alright? So the same thing, you have to perform the hypothesis testing, but specifically on the interaction term. Alright, this is for your interaction effect. Let's look at the T, the test statistic here. So 0.710. Okay. So you will have the same critical value here that you obtain from table. Alright, so since your test statistics value is less than critical value, again, we fail to reject H null or accept H null. So the conclusion is the interaction term is not significant, therefore, it is not needed in the model. That is why the question asks you to evaluate the necessity whether the interaction term is necessary to be added into the model or not. So because the interaction term is not significant, therefore we can say that it is not included in the model. There's no need to be included in the model. Alright, then the last question, I think, if I'm not mistaken, determine the 95% confidence interval for beta and interpret the results. So here how you can determine the confidence interval. So this is the formula. This is again, you can obtain from the statistical table. This is your regression coefficient. Alright, this is the regression coefficients. So you just substitute and you can get the lower limit and the upper limit. So that's how you answer the question of constructing confidence interval for the regression coefficient. So I think that's all. Thank you so much for watching.